In this lecture, we will learn about the template method design pattern and how to implement it in Python. Template method is a behavioral design pattern that defines the skeleton of an algorithm in the superclass, but lets subclasses override specific steps of the algorithm without changing its structure. We use this pattern when we want to let clients extend only particular steps of an algorithm, but not the whole algorithm or its structure. Or we can use it when we have several classes that contain almost identical algorithms with some minor differences. As a result, you might need to modify all classes when the algorithm changes. Let's look at the pros and cons of using the template method design pattern. The advantages of using this design pattern are that you can pull the duplicate code into a superclass, and you could let clients override only certain parts of a large algorithm, making them less affected by changes that happen to other parts of the algorithm. The drawbacks of using template method are that some clients may be limited by the provided skeleton of an algorithm, and that template methods tend to be harder to maintain the more steps that they have. Let's learn how to implement the template method design pattern in Python. We will create a class named AbstractClass. Inside of this class, we will define an operation1 function that takes in the self parameter. Inside of this function, we will print performing operation1 to the console. Then we will define a function named operation2 that takes in the self parameter. Inside of this function, we will print performing operation2 to the console. Next, we will create a function named operation3 that takes in the self parameter. Inside of this function, we will print performing operation3 to the console. Then we will define a required operation1 function that takes in the self parameter. Inside of this function, we will use the pass keyword. Then we will define a required operation2 function that takes in the self parameter and uses the pass keyword in the function body. Finally will come two functions, hook1 and hook2, that use the pass keyword in their function body as well. Inside of our abstract class, we will now create a function named template method. It will take in the self parameter. Inside of the template method, we will call self.operation1. Then we will call required operation1. Next, we will call operation2. Then hook1. After that, we will call our required operation2 function. Then we will call operation3. Then we will call the hook2 function. Next, we will create a class named concreteClass1 that extends AbstractClass. Inside of this class, we will have a required operation1 function that takes in the self parameter. Inside of this function, we will print concreteClass1 performing required operation1 to the console. Then we will define a required operation2 function that takes in the self parameter. Inside of this function, we will print concreteClass1 performing required operation2 to the console. Then we will create a class named concreteClass2 that extends the abstract class. Inside of this class, we will define a required operation1 function that takes in the self parameter. Inside of this function, we will print concreteClass2 performing required operation1 to the console. Next, we will define a required operation2 function that takes in the self parameter. Inside of this function, we will print concreteClass2 performing required operation2 to the console. After that, we will define a hook1 function that takes in the self parameter. Inside of this function, we will print concreteClass2 hook1 to the console. Then we will create the client class. Inside of this class will be a client code function that takes in two parameters, the self parameter and the parameter named AbstractClass of type AbstractClass. Inside of this function, we will call the AbstractClass's template method. Time to test our code. We will create a variable named client that we set equal to a new client object. Then we will call client.clientCode and pass in a concreteClass1 object. After that, we will call client.clientCode and pass in a concreteClass2 object. When we run the code, you will notice that concreteClass1 performed its methods and concreteClass2 performed its methods, both of which stemmed from the template method that we created inside of our abstract class. In the next lecture, we will learn about the visitor design pattern and how to implement it in Python.